One of today's most prominent and advanced physicists has expressed his opinion on the matter. Michio Kaku, recognized for his outstanding contributions to the field of physics, has recently confirmed that the James Webb Space Telescope, JWST, has discovered 6 massive galaxies that scientists thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. The discovery is both exciting and revolutionary, challenging existing theories about the formation and development of galaxies. It is therefore worth keeping an eye on these developments. The confirmation by such a distinguished scientist as Michio Kaku underscores the importance of these findings. Michio Kaku is an outstanding figure in the scientific field. A physicist of American and Japanese heritage, he is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the amazing results of the James Webb Space Telescope mission. His willingness to embrace new discoveries and share them with the public highlights his commitment to advancing our understanding of the universe. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amused tone of the renowned stellar physicist are evident in his comments on the discovery made by the James Webb Space Telescope, expressing that this has been a highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Kaku's openness to new theories. Michio Kaku is a scientist who has always been willing to consider new theories. Throughout his life, he has demonstrated an openness to ideas that challenge the status quo, understanding that Einstein's equations of relativity and Newton's laws, while foundational, are insufficient to capture the full complexity of a universe. Kaku understands that the discovery made by the JWST has the potential to enrich the scientific field. However, many of his colleagues have not been able to adopt this view. It is generating concern and even insomnia among proponents of the Big Bang Theory and opponents of quantum mechanics. However, this only provokes laughter from Kaku. The JWST has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of astronomers who made the discovery have dubbed these exceptional galaxies universe breakers because, if confirmed, they would revolutionize our entire understanding of the universe. The implications of these findings are profound, suggesting that the universe's early years were far more dynamic and complex than previously thought. A challenge to the Big Bang Theory. Something doesn't fit anymore. The Big Bang Theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for objects to reach sufficient density and produce light. The formation of complex structures such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size. Their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy forms stars only sporadically. It remains uncertain exactly when the first galaxies formed, as researchers have not been able to determine this so far. The only clear conclusion is that initially there may have only been single stars or groups of stars which eventually joined together to form larger and larger accretions until dwarf galaxies developed. These small galaxies encountered other galaxies and gradually grew. According to previous theories, highly organized and massive galaxies could not have existed at that time. The evolution of cosmology. The Big Bang Theory was established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies seemed to support this theory. However, science has shown time and time again that re-evaluation and openness to new ideas are integral parts of the scientific process. Understanding redshift. Researchers use redshift as a tool to determine certain properties in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, imagine standing still and seeing a car coming toward you. As the car moves closer, you hear the sound of the engine getting louder. However, once the car passes and moves away, the sound of the engine changes. The same is true for light. When a light source moves toward us, the light shifts toward bluer hues. When it moves away, the light shifts toward redder hues. Physicists convert redshift values into velocities and distances for measurement in cosmology. However, small errors in these measurements could have significant effects, and previous measurement techniques are currently under review. Final thoughts. Right now, we are witnessing a scientific revolution. Scientists expected the James Webb Space Telescope to confirm assumptions related to the Big Bang Theory, but instead it has revealed 6 galaxies that seem impossible. This reminds us that science is constantly evolving. Scientists must be open to new discoveries and rethink existing theories based on the available evidence. The unexpected finding challenges our current understanding and prompts a reassessment of long-standing cosmological theories. The role of the James Webb Space Telescope, JWST, in revolutionizing astronomy. The James Webb Space Telescope, JWST, is the most powerful space observatory ever built, designed to peer deeper into space and further back in time than any previous telescope. Equipped with state-of-the-art infrared instruments, JWST allows astronomers to detect faint celestial objects that were previously beyond our reach. This unprecedented capability has already yielded transformative discoveries, including the detection of unexpectedly massive galaxies in the early universe. Such findings challenge existing theories of cosmic evolution and raise fundamental questions about the processes that shaped the first galaxies after the Big Bang. One of the most astonishing revelations from JWST is that these ancient galaxies appear to be too large, too bright, and too well formed to fit within conventional models of early galaxy formation. If confirmed, this suggests that either the universe is older than we think, meaning our calculations of cosmic time need revision, or galaxies formed much faster and more efficiently than previously believed, requiring a major overhaul of our astrophysical models. This forces scientists to reconsider how matter coalesced into large structures so quickly after the Big Bang, and whether alternative cosmological models might better explain the evidence. Are we on the verge of a scientific paradigm? Scientific progress is often marked by paradigm shifts, where old theories give way to new models that better explain observed phenomena. History has shown that many once established ideas were eventually overturned by new evidence. For instance, the geocentric model, which placed Earth at the center of the universe, was widely accepted until Copernicus, Galileo, and Kepler demonstrated that the Earth orbits the Sun. The Newtonian view of gravity dominated physics until Einstein's theory of general relativity provided a more accurate description of spacetime. The steady-state theory, which suggested that the universe had no beginning and was infinitely old, was widely accepted until observational evidence confirmed the Big Bang theory in the 20th century. Now, with JWST uncovering evidence that contradicts certain predictions of the Big Bang model, we may be witnessing the next major shift in our understanding of the cosmos. Alternative explanations. Are there other theories that fit the data? If the Big Bang theory fails to fully explain these new discoveries, what alternative explanations might be considered? Some physicists and cosmologists have proposed various theories that could account for JWST's findings.